And me, in advance of this webinar, we were thinking about suitable and interesting topics for one of our webinars. And due to two main reasons, the idea came up with focusing the topic from today. So first of all, we recognize at our customers that the demand for automation solution or for smart automation solution is increasing day by day. And this has different kind of reasons. One reason, for example, is that the labor costs globally are increasing. So this is not only something which we recognize in Europe or in Germany. So this is something which we recognize in Asia and China as well, but also in the US, in America. Everybody, labor costs are increasing, and these are automatically guiding our customers into the area of smart automation solution. Secondly, a lot of our customers see a lack of specialists in the market, so it's not so easy to run our machines. You need specialists, and these specialists are not so easy to find on the market, and that's why this also guides our customers in the direction of smart automation solution. So very often we receive the question if we can also deliver a specialist, an application engineer, together with the machine. So this shows us that a lot of customers are really facing this problem, and one solution can be to automate simply machining processes. And last but not least, a couple of years ago, so we recognized that our customers are focusing on the investment costs, and today they are more focusing on cost per piece, investment per piece. And so the efficiency of the automation cell becomes a basic element of their decision. And this also guides our customers, as I mentioned already, in the segment of automated processes. So this is one aspect. So automation demands are increasing. Second aspect is that EMAG is well known in the automotive industry, in the mass production. So I think we have high references in the OEM business. But we made a lot in the past years. So we made modular machines. So one of these modular efficient machines I will introduce to you live in our shop floor during today's webinar. But we do not only developed and designed modular machines, we also designed in the past years modular automation solutions. And these price-efficient solutions are, from our point of view, the right answer for small and medium-sized batch sizes. And that's why Daniele and me, we decided to make this topic as the topic of today's webinar. Before I start with a webinar, please allow me to give you an overview about the next 60 minutes. So we subdivided the webinar into 4 blocks. The block number 1 will be a very brief introduction. So we in Saarland, at EMAG, we are thinking vertical. So I would like to let you know what are the advantages of the vertical machine concepts, but also what are the limits and what are the disadvantages. In the second step, I would like to introduce to you our duo concept. And in our shop floor, we will show you one VL3 Duo live. So this machine will be introduced to you directly at the machine. Afterwards, we come to the main focus of our today's webinar. This is the practical part. So we will show you how to switch or how to retool our VL3 Duo from part number 1 to part number 2. And yeah, this will be the main topic of this webinar, and this will be part number 3. And last but not least, just to make it complete, we will also let you know also quite complex, quite efficient automation solution for the mass production. So we don't want to focus the mass production processes, the high volume batch sizes for today's webinar, but at the end, I would also like to introduce you some other solutions from EMAG. So let's start with a brief introduction. So I told you EMAG is thinking vertical. So it doesn't matter if we are talking about turning machines, if we are talking about also other technologies like gear hobbing machines, like hardening machines. They also very often follow the vertical principle because, as I told you, we see a lot of advantages in this machine concept. By the way, EMAG introduced to the world market in 1992 during the METAF exhibition in Düsseldorf. So EMAG was one of the first machine tool manufacturers who were introducing to the market a vertical pickup turning machines. And from 1992 to today, EMAG step by step developed to the market leader of vertical pickup turning machines. And yeah, please allow me to briefly give you, from my point of view, the main advantages of this machine concept. So I would like to explain this principle to you on the example of our VL2 machine. So this is one of our entry level machines. So our modular machines, which first of all, if you recognize, or if you have a look to the machine concept, you will recognize that our working spindle, the main spindle, is not horizontal inside the machine. We lifted it up and it is integrated in the machine concept as a vertical pickup machine. And this gives the big advantage that the main spindle does not only doing the machining process, it is also responsible for the loading and unloading of the machine. And as you can see, the O automation, where the application engineer can directly put on the raw and the raw parts on, and he can take off the finished parts. This is always the standardized standard compilation of our VL machine concepts. So the automation is already included in the machine concept, and the pickup spindle does not only machine the part, it is also responsible for loading and unloading the machine. Optional, our customers also have the possibility to integrate a measuring probe between the working area and the automation. And this is the third work, or the third responsibility of the main spindle. So it's doing the machining process, it's doing loading, unloading, and it's also doing the measuring process if this is needed and requested by our customers. Another big advantage is if you lift up the spindle to a vertical orientation, the footprint of the machine becomes very attractive, and especially in the mass production, or also in the medium-sized machine production, space is very often the limitation of our customers. So this is also a second big benefit of the vertical turning machines. And last but not least, we also have a perfect chip flow. So you can imagine if you have a vertical spindle and you have the workpiece on the top, so every chip is falling inside our chip bin, and last but not least will be carried out by our chip conveyor. So the chip flow is more than perfect and the best solution, and this is very important for automated processes. I guess the machine concept is not well known by each of you, so that's why please allow me to explain you the VL machine, or the VL2 machine concept, more in detail in our 3D animation. As you can see, in the first step we have our chip bin, which is the basis of the machine, and then you can see our column in the middle of the machine as the basement. It's made out of polymer concrete. On the polymer concrete we put our spindle with the guideways and also with the ball screw. On the right side of the machine there is the carrier for the turret. Afterwards our turret will be integrated there. It can be equipped with BMT interface or with VDI. Here you see our touch probe, which is between the working area and the automation. And on the left side of the machine you see our O automation, which is always in standard. If we turn the machine around, so on the back of the machine we have our electrical cabinet and we have our chip conveyor. So all components which are needed in order to service our machines are easily accessible from the back side of the machine. So this is the principle of our machine. And now, as the last spreadsheet of the first part of the presentation, please allow me to show you a comparison of vertical turning machines in combination, or we want to want to show you the difference to horizontal machining concepts to each other. So these are standalone machines where the operator has the raw parts chip in, or the raw part bin and the finished part bin in front of the machine, and one operator can easily load and then unload on a manual basis easily minimum 3 machines, and the does only need to be opened for a tool change. So if there is no tool change, all the three spindles are always running, and for loading and unloading you do not need to touch the process, you do not need to open the machine, and this is a big advantage compared to horizontal concepts. If we switch this production philosophy to 3 horizontal machines, there is a big difference that the door of the machine does not only need to be opened for changing the tools, for changing the carbide of the tools. You also need to open it when you want to change the workpieces. So if one part is finished, you need to stop the machine, you need to open the door, take out the part, put in a new part, close the door, and press cycle start. So you always lose some seconds. And if we consider different kind of parts, we always have the feeling that this is our experience, that this makes the process 10 to 12 or 15% more efficient, because you do not have these I call it standstill phases of the spindle. So the spindles are always running. The operator of pickup turning machines can also leave the machines to have a coffee break, or even if there is a 10 or 15-minute break, it will not interrupt the machine. It will not, or the efficiency of the process will not drop down due to that. So this is a big advantage. Talking machine number 1, a standalone machine, vertical pickup turning machine from EMAG. Yeah, now I would like to introduce to you the practical part. So we decided to show you how to start, how to change, or how to do a tool change for the BL3 Duo. So at the beginning, I would like to give Mr. Bötzl or Uwe the sign so that he starts to run the machine. So Uwe, please start the machine. In the meanwhile, I would like to give you an overview about what we are doing now. So first of all, just a view inside the machine area. So this is a pickup, so the spindle picks up the part. Now the machining process is running. Afterwards, the part can be measured, and it will be brought back by the spindle to the pickup again. So yeah, you can see the loading unloading process, as you can see here now, live at our machine. So yeah, this is the pickup principle which I introduced to you and makes the machine process also from machine number 1 much more efficient. So as you can see here, we have 2 different kind of parts. So this part, which is a typical part for EMAG, this is a gear. So this part is now installed on the machine, and the process, the BL3 Duo, is running this part. So this is the track motion is loading and unloading the 2 spindles. It's flipping around the spindles. So the machine is running with a gear. And the intention of our today's webinar is to subdivide the retooling process into all different kind of sections, and to let you know and to show to you that each individual section is very easy to handle. So we will show you how to change this gear to a planetary gear. So this is soft turning of a planetary gear, OP10, OP20. So step by step, we will show you what needs to be done to do the retooling from part number 1 to part number 2. So due to the fact that we have the BL3 Duo inside the shop floor, please follow me so that I can introduce to you the machine concept in detail. So the BL3 Duo was introduced to the world market during the AMB exhibition 2016. So, and after the introduction on the exhibition, it became the most successful market launch in EMAG history. So we sell around 150 machines a year, so 300 spindles. So this is quite a high volume for just one machine type of vertical pickup turning machines. And it simply became one of our top sellers within the group. What are the reasons that that this product is so successful? From my point of view, one of the main reasons is the very small footprint. So this is a machine which has a working area to enable to machine parts of a diameter 150 and of a part length of 110. And on this small footprint, which only needs a requirement of 4.6 square meters, on this small footprint, you have two separately working areas. And working area number one, you have one spindle, you have one turret. Then you have a second working area with a second spindle and a second turret, and they can work independently. So normally, our customers are using this machine concept to do OP10, soft turning or hard turning of site number one, and OP20, soft and hard turning of the site number two. Second reason, from my point of view, which makes the VL3 Duo so successful, is our CNC control. So in this case, the machine in standard is equipped with a FANUC 31i, and this FANUC 31i is in standard equipped with a 4-channel concept. So you can run working area number one in channel number one. So you can program the machining process of OP10 in channel number one. On channel number two, you program the OP20, so the machining process of the second side of the part. In channel number three, you can program our modular automation system, the so-called track motion. I will introduce to you in detail later. This will be programmed in channel number three, and in channel number four, you will program our raw and finished part conveyor. So only one manufacturer who delivers you everything: machine, automation, raw part, finished part conveyor, and also who allows you to run all components and all systems with one control only. So if you buy a machine and if you buy from a third party and automation, you always have minimum two controls, and then you always have to work on the interfaces. Our efficient cell, the VL3 Duo, with a track motion system inside the machine and the raw part, finished part, can be controlled by one CNC only. This is a very big advantage.
Jan, can I interrupt you a second?
Sure.
What is always important, and for our customers, they are always curious to see how deep is our production of the main components like spindle or turret and everything. Can you explain this please a little bit in detail?
Sure, thank you very much. Yeah, this is right. So from my point of view, if you want to deliver high sophisticated automation processes, you need to have the core competence still inside the company, and this is also the philosophy of EMAG. So we have two production facilities, and in all production facilities, we are doing from step number one until the last screw, we are doing everything in-house. So we have our own foundry where we are doing the polymer concrete machine basement. So we are doing all mechanical parts, for example, of the main spindle. So this is always a water-cooled, direct-driven spindle. All mechanical components are machined by ourselves. We are doing the assembly in-house. We are doing the testing in-house. And what I just told you for the main spindles also counts for the turret. So this is not a turret which we purchase from a sub-supplier. It's our own EMAG turret. It's also water-cooled in standard and with a torque motor for fast idle times, also in standard. Every core competence is still inside EMAG. So we are doing also the cover of the machine. We have a powder coating possibility or machine in our production. So we are also doing this in-house. So as I told you, from the basement of the machine, which is done in our foundry, until the last screw of the metal sheet of the of the cabinet. Everything is done in-house, and this allows us to flexibly follow the requests and the needs of our customers. So this is a big advantage, you're right.
Thanks to Björn.
So after introduction of the machine, I would like to flip over to the raw and finished part conveyor. So in this case, it is equipped with a so-called stacker pallet. So the stacker pallet is a very efficient and easy possibility to stack different kind of parts. So this allows us, in this case, to stack up to 400 pieces on our VL3 Duo. Later, I will show you how easy it is to adjust the diameter of the stacker pallet, so that you can easily retool also the stackers and to change it for different kind of geometries for your workpieces. You see currently that the machine is equipped with stackers, but it is also possible to equip the machine with a more simple solution. This is a so-called carrier, and this carrier can also be added to our conveyor. And this conveyor, by the way, is also designed and manufactured in-house. So this is also our EMAG solution. And in standard, it always has a chain which is driven by a motor. And inside the elements of the chain, you can easily take off the stackers, and you can take off all, and you can also equip it and run it with these simple carriers. If you have if our customers have the requests in order to not destroy or not to scratch the parts, normally our customers go to pallet solutions. I can show it to you at the neighbor machine. So here, for example, for shafts, our customers, or even we deliver it to our customers, there's a possibility to do different kind of pallets. And same concept, there is also a chain, and you can easily add these pallets to our conveyor system. So different solutions, whatever the customer needs, whatever your customer needs, can be realized by EMAG. Now I would like to kindly ask you to follow me to the back of the machine so that I can introduce to you the track motion, the automation system, more in detail. So first of all our modular machines, they always have space, or that they have a tunnel behind the working area in standard. So this tunnel can be used for automation process. So if you want to use the machine with an O conveyor only, for example, a VL2, which I introduced to you earlier, then this tunnel is covered by a metal sheet. But if you want to do an automation process and you want to automate the process by our track motion system, you simply open it, or we open it for you, and we integrate our track motion solution directly inside the machine concept. So if I put a focus on, if I put your focus a little bit more on the track motion, you have to know that we have two main components. Component number one are our so-called tracks. So the tracks are standardized, and they have sizes of 300 millimeters, 600 millimeters, or 1,200 millimeters. So these standardized elements allow us to make to design automation solution dedicated to your individual needs. If you need it 1 meter longer or 600 millimeters longer, we can simply do it. You can add whatever, a washing device. So we are very flexible in this regards, and these tracks are the main component number one of our so-called track motion. The second part, or main component, is the so-called translift. The translift has the responsibility to pick up the raw part, bring it to the machine, take off the pre-finished part of spindle number one, flip it around by 180 degrees, and bring it to spindle number two. So this is a solution which we sold already 1,000 times, more than 1,000 times around the world. And this is our solution number one, which we can offer to you as a very flexible and very modular solution. In this context, I need to let you know that the track motion, which you see here, is not running full speed. So this is a customer machine, and we cannot fix all track motions for each individual customer here. So as you can see, the tracks normally need to be mounted or fixed at the production hall, but just for doing the pre-acceptance, normally we are not doing it, and then you cannot run the track motion full speed. You have to consider that the speed of the x-axis of the transmotion is up to 150 meters per minute. So and you need a high acceleration, and it needs to be break down in quite a short time. And this is only possible if you fix the track motion in the production hall. But we decided that this is not the main focus of today's webinar. So we don't want to show you the feats and speeds of the track motion. We want to show you how easy it is to change from one part to another one. And that's why we said, okay, we accept it, we explain it. This is what I did now. But I can show you a video, and that's why I would like to go back to the presentation screen again, just to show you how fast the track motion is normally running into the production of our customers. Before I start with the video, let me introduce to you the main technical features of our track motion. So we always have two different kinds of sizes. So one track motion size is the so-called track motion 4-20. So 4 means 200 millimeters workpiece diameter maximum, and a workpiece weight of 20 kilograms. We also have a stronger, bigger sister of the TM4. It's the so-called TM8-70, and this can handle parts up to a workpiece diameter of 400 millimeters and a maximum workpiece weight of 70 kilograms. As I told you, most important is the acceleration. So we have or the speed of the x-axis, and our customers are running the track motion normally with full speed, which means 150 meters per minute. If you consider that our x-axis of the VLC Duo has 60 meters per minute, this is more or less 3 times higher. So you can imagine about what forces we are talking about, and this is only possible if you fix the tracks inside or at the production hall floor. Last but not least, I would like to mention you can also add a second translift on our tracks. So whenever the cycle time or the cycle time of the is quite small, then sometimes you need a second translift in order to handle the automation. So this is also possible. You can also add a second translift, and then one translift is handing over the parts to the second one, and this makes the automation process even more efficient. But this will be calculated by our specialists if 1 or 2 translifts are needed. Now I'll show you the video. So this is a full speed track motion video. So the track motion is picking up what you can see here, the pre-finished part of spindle number 1. It flips around the part, hands it over to the L conveyor of spindle number 2. Then the finished part is being picked up, and the track motion is going back to the raw and finished part conveyor. So yeah, again, finished part is picked up at the stacker. It is handed over to spindle number 1. Then the pre-finished part is picked up, flipped around by 180 degrees. It will be brought to spindle number 2, and then full speed back to the conveyor. Yeah, this is what I want to show you.
Björn, from
Yes.
our audience is coming the first question.
Okay.
How many pieces do you need to automate when we use which automation concept? Linear automation, gantry, or robot? Yeah, I think it makes sense, like we have seen now from Björn, in this kind of solution makes sense from 20 to 50 parts to automate when we have a standalone machine. When we have high volume, we are speaking the automotive business, like up to 100,000 or more or million parts, we are using then linear gate automation, and then also with robot solution. but it depends also from the philosophy of the customer. If he has more the philosophy to use gantries or robots, it depends from the footprint or other issues or, let's say, requests from customer side.
Okay.
You have to add something, Björn?
No, that's it. As you just mentioned, standalone machine, from my experience, 20 to 50 parts is a good volume to start with. So whenever you have enough parts to fill the O conveyor of a VL2 machine, for example, then it always already makes your process efficient and 10 to 15% easily more efficient than a horizontal turning machine. And this machine, the VL3 Duo, now with the stacker system, this has a capacity of maximum 400 millimeter parts. So this is the right solution for 200 to 400 parts pieces. And then if it goes to thousands and millions, you can be sure that we also find the right solution for you. So you're absolutely right. Yeah, now I come to the main part of our webinar. This is the retooling of part number 1 to part number 2. And yeah, this is the right point to hand over to Uwe and to give Uwe the sign. So Uwe, please start the retooling process. So I will explain you briefly what he's doing. So he's pressing the button called, or the cyclist M01. What does M01 cause to the machine? So now spindle number 1 and spindle number 2 will finish their machining process. So normally the process is currently running. If you interrupt it by cycle M01, then first of all, the machine needs to ensure that the machining process is finished in order not to create any O parts. If this is done, the machine will give an alarm to the application engineer, and then the machine switches from the automatic process to the manual process. And then we will show you what you need to do in order to change the part in the next steps. So Uwe, is the machine still running? Okay. So as you can see, spindle number 1 is already finished. Spindle number 2 is also already on the pickup. So it can only be a question of a few seconds until it's done. Okay. So now it's done. So he's pressing the reset button. And then the first step of interrupting the machine is done. Afterwards, we need to ensure that we have access to the finished part of process number 1. So as you can see, now Uwe is manually rotating the stacker pallets so that he has direct access to the stacker pallets, and that he can take off batch number 1 or the workpiece number 1, and he can put manually on the stackers the second part. So we are still in the manual machining process. So now Uwe is taking taking off the parts, and he's putting on the part number 2. So this takes some more seconds. So I would suggest we let Uwe do his job. In the meantime, I will introduce to you the machine concept of the VL3 Duo based on a 3D animation. So if you want to understand how the machine works, I think it is worth to have a look on the automation process. Yeah, this is the VL3 Duo, which I just introduced to you directly in the shop floor. You see the machine, you see the raw part, finished part conveyor. In the back, you see the track motion. So what you see here is that the pickup spindle picks up the raw, or first of all, takes out the pre-finished part. It picks up a new raw part. Now you see machining process number 1, so the OP10 of the first side of the part. And yeah, this is a part which we also integrated in our webinar. So this is also a planetary gear where you are doing the internal turning processes, the outside, the OD turning processes. And afterwards, there is a measuring process, which you can see here. It is taken out of the working area. And afterwards, yeah, the track motion is taking over the part, is flipping it around by 180 degrees, and it is handed over to the L conveyor of spindle number 2. So after the translift brought the finished part to the raw and finished part conveyor, you can see that now the pre-finished part is ready to pick up for spindle number 2. It is clamped in the ID. So now you can see the machining process, the soft turning of the planetary gear on the second spindle. So I think if you understand this kind of machine process or the machine concept, it makes you much more, it's much more easier for you to follow the next steps. Yeah, so I just received the sign from Uwe. Mm-hmm. So the stackers, as you can see, they are now empty. So the machine is still in the manual modus, it's not running. And the next step, what Uwe is now doing, he is starting the cycle to take off all parts of the whole process chain. So in step number 1, so in Germany, it's called Leerfahren. So it's some kind of empty running of the whole machine. So please press the button. So this is also an automated process. So you have to understand that by pressing the cycle M01, we only ensured that the machining process of spindle number 1 and spindle number 2 was finalized. But now there are still machines, there are still parts on the L conveyors, there are still parts in the track motion. And now by pressing the button in Germany, Leerfahren, all parts are now getting out of the machining and automation process. This will take also some minutes, and in the meantime, normally the operator can use the time, and he can already put on the raw parts of the second machining process. And this is also what Uwe will do now. So he will parallelly already start to put on the raw parts of part number 2 inside our stackers. So while he is doing this, so he will put on now, or he will equip 2 or 3 stacker pallets with a new part, and we will also show you now how to easily adjust the stacker pallets to different kind of geometries. So if you open the or if you take off the screws, so that the mechanical the mechanical design is working, so you can easily change the diameter of the stacker. So whenever you want to grab the parts at the OD, this can be done. If you want to grab parts in the ID, so in the inside diameter of the workpiece, you can easily adjust it to different kind of geometries for parts. In order not to be able, or not that there is no need to do it for each different kind of pallet, we decided to use parts where the ID has the same diameter. This is just to save some time and not to bore you. So I think you understood how easy it is to adjust the stackers. But we can simply take off part number 1 and put on part number 2, just to make the webinar a little bit more efficient. Okay. Yeah.
Question from our audience, from our customer. We have no experience with such automated process. What support does EMAG provide? Yeah, we have not only on social media to see the videos about how we can set up machines, chucks, and let's say the tools. We have also the possibility when we offer machines to make trainings. We have our own academy. That means we can train everybody in a mechanical training or individual electrical training, also a control training for each solution. That means at least we can support you complete in the turnkey solution. We have the possibility to do a lot of trainings in this case.
Yeah, maybe something to add from my side. Yeah, we can deliver the machine with no technology, and if this customer has already hundreds of EMAG machines, so he normally is familiar with the machine concept. He can handle the machine on his own. If you as a customer wants to enter the world of vertical pickup machines, definitely it makes sense to get the machine running with your individual part already. And you can also do some trainings at EMAG Saarlach here in Germany. You can also do it in-house. So we also come to your facilities if this is requested. You will always get perfect documentation of the machine and especially of the control. So this is, for example, something where you can see the M functions and G functions. How they are used in the EMAG world. Everything is decided, is described in detail, so that you get very easily familiar with our control. You will also get some explanation how to make your process more efficient. So this is just one example what makes it quite easy for you to get familiar with our kind of technology. So I just received the sign from Uwe. So as you can see here, just a quick view. So we changed already the stackers. So the part number 2 is now manually put on the raw and finished part conveyor. And this is normally sequence number 1, which hopefully shows you that this is no rocket science and easy for everybody to follow. In a second step now, is that our customers change the chucks, or in most cases, the chucks are not do not need to be changed. Very often, only the jaws need to be changed, and this is also what Uwe is doing now. So on the left side of the machine, we have a 3 jaws hydraulic chuck with quick change jaws, and on the second side, we have a chuck with a spindle with a mandrel, and this mandrel is clamping the device inside the bore, and so different kind of chucks, but this is quite normal or quite common what we see at our customers very often. So on one side, OP10 clamping outside with a simple 3 jaws hydraulic chuck, and the spindle number 2 mainly is equipped with a hydraulic chuck and a mandrel. So you can see that Uwe now needs to change the jaws of the chuck. In some cases, it can also be, or there is also sometimes the need to change the chuck completely. So you do not need to be afraid of this. So due to the fact that the time is limited for the webinar, we didn't want to show it to you here, but I would like to invite you to visit our YouTube channel. And the EMAG YouTube channel is flooded with several different so-called how-to videos. And one video is how to change a chuck. And you can easily see that if everything is prepared, it takes maximum 15 to 20 minutes to change a chuck completely. So normally, if you need to do that, you need to make use of this supporting device. So this device is included into the interface of our turret. So VDI 40 or BMT 55. Then normally you drive with a spindle over this device. You take off the screws, and you put with the spindle, you put the chuck directly on this device, and afterwards the operator can take out the chuck, and he can put on the new chuck also on this device, can go with the spindle inside and fix the screws, and afterwards the chuck, the change of the chuck is also finished. So as I just mentioned, it's not part of our webinar today, but please be or feel invited to visit us on the YouTube channel and to see how easy this can be done as well. So in this case, Uwe, one moment. In this case, we do not need to change anything at the chuck number 2. So this is also because of the fact that the geometry of part number 1 and part number 2 are very similar. So the inside bore is the same, just to make it more time efficient for you and not to bore you. But normally the customers only need to change the mandrel. This is also not a big deal. And then this can be done now. So for our practical part, we are finished now with the change or with the adjustment of the chucks. And now I would kindly ask Uwe to move ahead. So now we need to go back to the automatic process again. So Uwe needs to make some smaller adjustments. One adjustment, for example, is he needs to inform the control which stacker pallets are equipped with new parts. So each stacker pallet has an individual number, and he now needs to say, for example, the first pallet which needs to be addressed by the track motion is number 8. So he simply needs to give this information to the CNC control. Afterwards, he needs to do some he needs to press some buttons in order to accept some different kind of things. So the machine wants to be sure that all the jobs which are needed have been realized by Uwe. So he has to accept several different kind of things. So all the things which you saw here. And now I see he already pressed the button, and we start again to the automation process or the automatic process. So the machine knows exactly which stackers are equipped with parts. So he's now bringing the right pallet to the pickup station, and then the translift of the track motion is doing its job. And if there are enough parts on the stacker, you can leave the machine. You can leave the machine overnight. So that's why this machine is quite a success worldwide, and this is why it's also why our customers like this machine concept. It's not so difficult to adjust everything, and if the machine is equipped with 400 parts, you can simply run the machine overnight without any application engineer beside the machine.
Jörn?
Yes.
We have a new question for our customers.
Okay.
Question is, I'm not much more flexible with 2 machines than with 1 double spindle machine. With 2 machines, only 1 machine stands still when the other is set up. Yeah, we have here the benefit that the machine, a double spindle machine, each machine has its own control. That means we can set up the machine on the left side. On the right side, we can still work independently. It means you have not to stop both areas. One area can still work, and the other one you can set up. Each machine or each working area has a separate channel. Björn, you want to add something?
I would like to add a proposal. So you're absolutely right. I hope I do not stress Uwe too much, but I would suggest that we simply also show it at the machine process. So this is a question we receive quite often from our customers. So what is if 1 spindle stands still? So first of all, what I can tell you, there's also the so-called agent this possibility. If, for example, you have a breakdown at spindle number 1, you can still run the machine with spindle number 2. So this is ensured. So normally, we are EMAG, definitely. It's not our intention to generate breakdowns, but just to let you know, whenever there's a breakdown, if the spindle broke or whatever, you can also run the machine concept with spindle number 2. You can also, if the track motion has a breakdown, you can see that there are 2 doors at the front in order to do the tool change, but there are also door number 3 and door number 4. So you can also open it, and then the operator has direct access to the pickup, and if the track motion has a breakdown, he can manually take off the part, flips it around, and put it to the right side of the machine. So this is not the intention, definitely not the intention of the VL3 Duo, but just I think this is important for you to know that this is also that we have a plan B whenever we are facing, or you as a customer are facing this problem. If I come back to this question, yeah, that's why I would like to look to Uwe. I would like to show you that it is possible also to do a tool change at spindle number 1, and the whole process, track motion, stacker, and spindle number 2 is still continuing the machining process. So are you ready to show it? So, okay, so we can show it. So Mr. or Uwe needs to make some changes. So if we just want to show you a tool change on spindle number 1, he simply has to tell the machine that now the tool change at the left side is planned, and afterwards the process on spindle number 1 first of all is finished. The spindle will move to the pickup and will give the best economic access to the turret which you need. So as you can see now, the spindle stops, and now the door must be ready to be manually opened by Uwe, and he can now do a tool change. Okay.
Björn?
Yes.
Here, our customer are really busy. We have another question. The question is...
So we give Uwe some time. We come back to the machine later.
We machine workpieces up to batch size 200 pieces, diameter up to 100 millimeter. The machines are set up every 2 days, chuck and tools. Is it worth using vertical lathes? Yeah, we have customer solutions where we are using vertical lathes, or our machines also with low sizes or low batches, up to 20, 30 parts. It makes absolutely sense. We have to say the VL3 Duo, which we are here presenting, has a maximum diameter 150, but we have other machines where we can turn only without problems diameter 200 millimeter.
Okay, we can come back. So sorry for stress you a little bit. So but now everything is finished. So door is open. So this is normally quite easy. If the spindle goes to the pickup, you can open the door, and you have direct access to the turret. You can take off the tool together with the interface completely, or you can also just change the carbides and then yeah, the carbides after, for example, a breakage. So this is not a problem, and the machine is still continuing and is still running. Okay, so if we, or I would suggest that we are now finished with this practical part of the machine of this webinar. So we just showed you step by step how to change the stacker pallets, how to change the chucks, or even just the jaws of the chuck. Afterwards, how to change the program. And yeah, from time to time, it also needs to be the track motion also needs to be adjusted. One last thing, maybe I didn't explain to you in detail. I just wanna maybe last but not least come back to the control again. So it was very quick, maybe too quick, and I need to explain it to you a little bit more in detail. So it's very common that a customer is purchasing a machine, and he has the idea to machine 10, 12, 15, or sometimes even 20 different kind of parts on the machine. So normally he has all the 20 programs inside the CNC Control already, and he simply, like Uwe did it during the webinar, he simply have to change from program number 1 to program number 2. Just to give you a feeling, if we are talking about a program, you always have to program all 4 channels. So the channel number 1 is the machining process of the spindle number 1. In this case, the machining process of OP10. In channel number 2, you need to program the machining process of OP20. In the channel number 3, you need to program the track motion. And for example, one thing you need to tell the control is, if you start from the top of the workpiece, where do you want the track motion to grab the part? Also, you can adjust the pressure of the clamping device of the track motion. So these things need to be added from time to time. You also can change or need to change the jaws. So this is a mechanical change. But yeah, as a third step in our program, you need to program channel number 3, so the track motion. And last but not least, you need to program the stacker, so which stackers are filled up with parts. So this is what you need to put in as information for the control in channel number 4. So if we are talking about one VL3 Duo machining program or CNC program, you always have to consider that there are 4 blocks which you have to program. But I guess most of you are already familiar with that. If not, we deliver you everything what is needed, our documentation, also our skilled people who can do training inside your shop floor, or you come to us, and then you can see it's very easy to change from one program to another one. The FANUC 01i also has the manual guide I function in standard. So normally our customers are programming the machine not directly at the machine, but at a notebook or at a desktop PC, and they are doing the program there. And afterwards, with the interface of the USB or with the Ethernet connectivity, we put the programs on the machine. But with the manual guide I function, which is similar to the shop turn from Siemens, which is a visual supported mask in order to make it very easy for the operator to do the programming directly at the machine. So you can come with a drawing, and you can come very easily from the drawing to the finished part with the manual guide I function. So there are different kind of ways how to program our machines. You can do it via M codes and G codes at the machine or at a desktop PC. You can do it directly on the machine, normally with manual guide I. So different kind of possibilities. And in this context, I also have to mention the VL3 Duo is also available with a Siemens 840 solution line control, and then also as an option with the shop turn functionality. And then yeah, you can also equip the machine with a Siemens control, and it's called VLC150 Duo. Now I go back to the last sequence of my presentation.
Björn, I have another short question from a customer about the turning. After jaw changing, jaws turning not required? Yeah, normally for fine operation or fine turning, it's required to turn the jaws, but it depends if we have a rough operation or an operation which the quality is not required so high, we have not to turn the jaws. And our chucks that we are using in the most cases are really balanced in a really good quality.
Yeah, I think there's not really a difference between a horizontal machining concept and a vertical pickup turning concept. So from time to time, it's simply needed to turn the jaws. So there's no difference of horizontal and vertical turning machines. What I also in this context would like to mention, so you can get the whole process chain from EMAG, machine, automation system, also the programs, the jaws which are needed for the track motions, for the chuck. Everything can be supplied by EMAG. And we are also a supplier of chucks. So for very complicated geometries, for example, like a diff case. So we are also doing the design and the production of EMAG chucks inside. So whenever this technology is needed as well, you can also hand over this responsibility to EMAG. So this is also not a big deal for us. So if there are no more questions, I go back to my presentation. So I give you a quick overview about the vertical thinking of EMAG. I introduced to you in detail the VL3 Duo. I introduced you directly in the shop floor our machine cell, the VL3 Duo with the track motion. Last, in the third step, I showed you if you subdivide the retooling process in different kind of sequences, each sequence is easily to be handled by our customers. So I think you're not scared about these kind of machines, but maybe after this webinar, you feel much more comfortable and maybe you're more open also to think about these kind of machining processes. And now in the last step, I would like to show you also some pictures of different kind of automation solutions which we offer. So from simple to complex, I would like to start with the standalone machine concepts, which I introduced to you in the beginning of my speech. So customers, a lot of our customers purchase standalone machines, and they benefit from machine number one already of the higher efficiency due to the fact that the spindles are never standing still. This is what I think you understood during my presentation in the beginning. Module 2 is the medium batch size solution. This is normally the integration of the track motion inside the machine concept. You can put 2 machines, 3 machines, or even 10 machines in one line, and you can put in the same technology like turning machine OP10, turning machine OP20, turning machine OP30, or you can also change from technology to technology. First machine turning, second machine gear hobbing, third machine roll chamfering or chamfer cutting. So then you have a gear line. So you can add same technology of machines in a row, or you can add different kind of technologies. And we also deliver different kind of robot solutions, which are very much demanded currently by the market. So in this VL3 Duo on the right side, so 4 spindles, 1 robot, and also measuring cell can be Lenat, can be Marpos, whatever you require and you request. We can deliver the whole cell, or we can deliver the machine only, and you are doing the robot cell adjustment on your own. So we are very flexible. We are as flexible as you request us to be. These are different kind of examples as well. Examples for track motion. The left side, number 1, you already saw within our webinar. So the VL3 Duo, OP10, OP20 in one machine. I forgot to mention you can also use the machine and with OP10, so same operation on spindle number 1 and spindle number 2. But this is, let's say, the entry level in getting familiar with our track motion, modular automation system. As I mentioned already, you can add same machines in a row, OP10, OP10, OP10. So whenever your batch size is increasing, you have a flexible automation solution which can increase as well. And what I also mentioned already, this is an example of a diff case. So a diff case normally has 4 operations, and here you can add different kind of machines. So these are 2 flange turning machines, VL4, then a shaft turning machine, a VT4, and last but not least, again, a VL6. So, but it can also be a different high technology VSC machine. So we are very flexible, and we, if you come with a drawing, what needs to be realized from you, we will give you the best solution from our point of view, and we are very flexible to find the best solution for your customized or for your individual request. And last but not least, 3 different kind of robot solutions: 1 machine, 1 cell, 2 machines, 4 spindle, 1 cell. Or we also made a completely hall layout at one of our customers in China. So he was purchasing 48 VL8 machines, which are pickup turning machines up to minimum 400 millimeters workpiece diameter. And this customer asked us to do the whole production or the whole layout of the production hall in order to machine for trucks the brake drums. So there we decided, due to the high volume, to put the robot on a linear on linear tracks, so very similar to our track motion here. And then we delivered everything, including balancing unit, produced and designed by EMAG. So we produced and designed everything for the customer, so that he has now 48 machines running 24/7 and doing brake runs. Yeah, that was the end of my presentation. So as I told you, we decided to focus on small size batch sizes. So our standalone VL 2, 4, 6, or 8 machines. So we have different kind of sizes. This was the focus of the webinar. And at the end, I simply wanted to give you also some ideas about what can be expected from EMAG on top.
Beyond,
any questions?
Another questions about quality.
Okay.
How is quality control implemented in automated machines? We have the possibility, like in the VS3 Duo, we can implement a gauge or a gauging unit. That means we have behind the machine or left or right side a gauging unit, which has an interface to our control where we can measure each diameter or tolerances and give a directly feedback to our control. Or we have the possibility also to implement in our machines the measuring probe, which can measure also diameters and lengths and correct them. But it's, let's say it's not a measuring machine, the measuring probe, it's only for rough diameters and rough lengths to measure. These are the possibility from our side to implement the quality in the machines.
Okay. Yeah, last but not least, thank you very much for
thanks a lot
for attending the webinar. So hopefully we reached our goal, so that you understood the retooling process. And yeah, thank you very much for attending the webinar. Hopefully we see each other again in our shop floors all around the world, in our showrooms all around the world, or on exhibitions or at your customer site. So I'm very happy to keep on getting in touch with you regarding this topic, the automation processes of EMAG. Thank you very much.
Thanks a lot.
And stay healthy.